Section 6.5 focuses on squares and rhombi. So in section 6.4, you learned about rectangles, and remember rectangles are parallelograms with 4 right angles, and they also have diagonals that are congruent to each other. Squares and rhombi we're going to find have some of the same properties, but also have some differences which distinguish them from each other. So first we're going to look at the rhombus. So a rhombus is a parallelogram with 4 congruent sides. So you got to remember all 4 sides must be congruent or it's not a rhombus. Don't confuse this though and think that it's a square if you have 4 congruent sides. We only know that it's a rhombus if all we know are 4 sides are congruent and it's a parallelogram. So it's a rhombus if it's a parallelogram and the diagonals are perpendicular. If a parallelogram is a rhombus, then each diagonal bisects a pair of opposite angles. If the diagonals of a parallelogram are perpendicular, then it's a rhombus. If one diagonal of a parallelogram bisects a pair of opposite angles, then the parallelogram is a rhombus. And if one pair of consecutive sides of a parallelogram are congruent, then it's a rhombus. So let's take a look at those. So the diagonals are perpendicular. You'll just find that these create 4 right angles. So if you know that diagonals are perpendicular, you'll know that it's a rhombus. If the diagonals bisect the opposite angles, then you know that it's a rhombus. So what this means is if we look at these 2 angles, we know that they're congruent because this is a parallelogram and the opposite angles are congruent. Well, if it's bisecting them, it's breaking these into 2 congruent halves. Well, if the 2 full angles are congruent to each other and the angles are being bisected, then we know all 4 halves are congruent to each other. And this happens up here with the top and bottom angle as well, so we know that these were congruent to each other as 4 halves also. If the diagonals are perpendicular, then it's a rhombus. That's just the converse of the first statement. And if the diagonals of a parallelogram bisect a pair of opposite angles. So if you can just prove that this one diagonal is bisecting these opposite angles, then you know it's a rhombus. And then last, if a pair of consecutive sides of a parallelogram are congruent, then it is a rhombus. So for example, if we know that, let me get rid of a few things so you can see. So if we know this side is congruent to that side, because remember consecutive sides are next to each other. Since this has to be a parallelogram to be a rhombus, then we would know the opposite sides are congruent, which would then make all 4 sides congruent, which would then make it fall under the definition of a rhombus. So remember those things, think about how you would use them in problems and proofs, and we'll discuss them some more. So for this problem, we've got diagonals of rhombus FGHJ intersect at K. And so they're telling you it's a rhombus. So if they're telling you it's a rhombus, you automatically know, okay, I have 4 congruent sides. I know the diagonals are perpendicular. I know the diagonals are bisecting opposite angles. That would mean this angle is congruent to this angle. This angle is congruent to that angle. This angle is congruent to that angle. And then these are congruent to those angles. And same thing down here. This angle is congruent to this angle, and we know these 4 are congruent to each other. So first we know that FK is 5, and we know FG is 13. So we're going to find KJ. So this is what we're trying to find. So if you notice, all 4 sides are congruent, so we know this side's also 13, this side's 13, this side's 13. And we know since the diagonals are perpendicular that we're dealing with right triangles. So if we have right triangles and we know 2 sides and we're missing 1, then we know we can use the Pythagorean theorem to solve this. So we're going to have 5 squared, and remember the hypotenuse is the longest leg across from the right angle. So FJ would be the hypotenuse. So plus, I'm going to call it KJ squared, equals 13 squared. So I want you to solve that and figure out what KJ would equal and bring that to class. Alright, problem B. So we know that this angle JFK So JFK, this angle is 6y plus 7. We know KFG is 9y minus 5. Since we know those angles are being bisected by this diagonal, we know that they are equal to each other. So we're going to have 9y minus 5 equals 6y plus 7. So I'm going to subtract 6y and add 5. So we've got 3y equals 12, and so therefore y equals 4. So take a look at these problems, make sure you're able to solve for KJ, and if you have questions, bring them to class to discuss. Alright, now for squares. So squares have 4 congruent sides, so we've got a couple of things to look at. So 4 congruent sides and 4 right angles. That's what distinguishes it from a rhombus. So a rhombus just has 4 congruent sides. Well, for the parallelogram to be a square, you have to have 4 congruent sides and 4 right angles. And then the only property you have for a square is if the quadrilateral is both a rectangle and a rhombus, then you know it's a square. So basically, if you can prove something's a rectangle and a rhombus, you know it's a square. So, are all squares rectangles? Yes. Are all squares rhombi? Yes. Are all rhombi squares? No. Are all rectangles squares? No. So keep that straight in your mind as you prepare for the quiz and tests, especially dealing with sometimes, always, never questions. So we have this proof. So we know segment SQ is the perpendicular bisector of PR, and segment PR is the perpendicular bisector of SQ. So triangle RMS is also isosceles, and we're trying to prove that this is a square. So what we need to do to prove that it's a square is prove that it's a rectangle and a rhombus. So we know the first reason is the given, and we need to add the name triangle RMS is isosceles. So to prove that it's a rectangle, you would either have to prove that there are 4 right angles, which we don't know much about the angles, so that might be hard to do. We could prove that the diagonals are congruent, which would probably be easier. And then to prove that it's a rhombus is to prove that the diagonals are perpendicular. So let's start with proving that it's a rhombus, since that'll be easier to do. So if SQ is the perpendicular bisector of PR, and PR is the perpendicular bisector of SQ, then we know that SQ is perpendicular to PR by the definition of perpendicular bisector. Under that same reason, we could also include that segment SM is equal to is congruent to segment MQ, and that segment PM is congruent to segment MR, just because that all falls under the definition of a perpendicular bisector. Well, now that you've proven the diagonals are perpendicular to each other, we know that this is a rhombus. And that's because we know the diagonals are perpendicular to each other. And so next we need to somehow prove that the diagonals are congruent, and then once you prove the diagonals are congruent, you've proven that it's a rectangle. And so your last step will be that PQRS is a square because it's a rhombus and a rectangle. So I want you to finish this proof up, bring it to class, we'll talk about it and discuss correct methods and incorrect methods, and you should be able to finish this, so I want you to try it and just bring it to class to share. Alright, last thing I want to look at is this Venn diagram. So what this shows us is the relationship between parallelograms, rhombi, squares, and rectangles. So the thing to remember is that the parallelograms include anything inside of this rectangle. So what that means is all the rhombi, squares, and rectangles are parallelograms. So what this shows us is where the rhombi and rectangles overlap, that's where the squares are. So just remember all this. We're going to add some more shapes to this. We're going to have a trapezoid and a kite. But for now, just focus on those.